Yeah, good evening, everyone. Beautiful evening to you. Yeah, welcome, everyone. You're welcome, you're welcome, you're welcome. Yeah, we thank God. And that was yours too. Yeah, good evening, everyone. Good evening, you're welcome. Yeah, good evening, welcome. Good evening, everyone. Good evening. Once you're joining, just give us a thumbs up immediately. Let's get this video on maximum thumbs up. All right. Yeah, good evening. Yeah, good evening. You're welcome. You're welcome. Yeah, try and inform your people that we are starting already so that at least everyone can participate in today's revision. Try and inform your people, your friends that we are starting already. I hope I'm audible. Can you hear me, please? All right, okay, that's good. You can hear me. That's good. Okay, so we'll be starting any moment from now. Today's class is going to be quite intense because we want to cover up several topics. All right. We want to touch topics relating with matrix, questions relating with matrix. We want to talk about trigonometry. We want to talk about binomial expansion. We want to talk about function and mapping. We want to talk about polynomials. We want to talk about binary operation. We want to talk about real numbers. We want to talk about everything possible. So, guys, you have to uh, ensure you are very much uh, focused because I would not be, one of the things I want to do is I may not be solving too many questions. As you can understand, this is a revision class, so we don't have the time to solve many questions. Sometimes I may not even complete some of the questions. I just want to bring to your remembrance all these different concepts so that when you see them in the exam hall, you can relate better. All right. So that's what we want to really do today. I will be giving you the concept, reminding you of all the concepts of several topics, if possible, every topic. And wherever we stop today, we'll continue tomorrow. All right. So I believe we're good. We're good to go. So we'll start right now. All right. Now, so welcome everyone. Uh, in today's class, we want to start from the very first topic we started with, and that was matrix. So let's start from topic one, matrix. All right. All right. So the very first, this was the very first topic I believe you all came across while getting into this program. And what is matrix? Of course, this is a set of rectangular arrays arranged in rows and column. So we all know what matrix is already. So when we have 1, 2, minus 7, 3, this is a 2 by 2 matrix, all right? And when we have 1, 3, minus 4, this is a 3 by 1 matrix. So how do we locate the 2 here? This 2 is the row. That means we have 2 rows. This is the column. While this is the row and this is the column. We count the row this way. 1, 2. All right. That's why we have 2. And we count the column this way. 1, 2. That's why we have 2. We count the row like this again. So 1, 2, 3. That's 3 by 1. Just one column. All right. Now let's run quickly to operations in matrix. So we have different operations in matrix. We have the addition, we have the subtraction, we have the multiplication, we have several. We have the trace, we have the inverse, we have. So let's get into them right away. Please, can you hear me? Can you please indicate if you can hear me? Because we're doing more of revision, and we're going to be going through several topics. All right. Please, can you indicate if you can hear me? I'm not sure if, okay. All right. I want to confirm if you can hear me. So now, matrix addition, just to remind you, if you have matrix A and matrix B, these two matrices cannot be added together except they have the same order. This is what we call order, right? This is the order of this matrix, 2 by 2. This is the order of this one, 3 by 3. So in this case now, these two matrices cannot be added together because they don't have the same order. We can only add two matrices together if they have the same order. That means you can add a 2 by 2 with a 2 by 2. You can add a 3 by 1 with a 3 by 1. Anything other than that, it cannot happen, all right? Same thing goes for matrix addition or subtraction. You can only subtract two matrices if they have the same order. So once you discover that these two matrices don't have the same order, you cannot make subtraction on that matrices. So let's run quickly to multiplication of matrices. Now, you don't have to have the same order while trying to multiply matrices, but there's a rule of thumb you must always remember. When dealing with multiplication of matrix, this is the rule of thumb. These are two matrices now, matrix 1, matrix 2. Look here, this is the row 2, this is 2, this is the row 3, this is the column 1. So now, if you're going to multiply two matrices together, the rule of thumb is that the column of matrix 1 must be the same as the row of matrix 2. That means in this case now, the column is 2, the row is 3. So we don't have the same row and column, number of rows and column here. So we have 2 here, we have 3 columns here, 3 rows here and 2 columns here. We cannot multiply these two matrices together. So the only kind of matrices you can multiply together are matrices that have the same rows, the same column 1 is the same as row 2. So if you have, for instance, let's say you have 2 by 2 and we have a 2 by 3, for instance. Let me give you a 2 by 3 matrix in case you have, I hope you have not forgotten that. Minus 1, minus 3, 1, 2, 5, 6. Now this is a 2 by 3 matrix. Now you can see right here that we have column here is 2, row here is 2. These two matrices can be multiplied together, and the resultant will always be whatever is left here. So we have 2 left here, 2 by, so your solution will always, if you multiply these two matrices together, you must get a 2 by 3 matrix. This is just a revision class, don't forget. We're going into several topics today, so just hang in tight. We will not be able to go very deeply to each and every one of them, but we'll try our best to bring all the basics so that you guys can remember it. So now, I believe you should know how to multiply a matrix together. Let's say, for instance, we have 2, 3, 4, 5. I'm not going to do this completely, just for you to have an understanding, that's all. Let's say we have 2, okay, let me just use this. Now look at these two matrices together. We have, this is a 2 by 2 matrix. This is a 2 by 1 matrix, all right? I'm sure nobody is here that is making is getting this wrong. This is a 2 by 2 matrix. This is a 2 by 1 matrix. Now, I look at the column here. I look at the row here. They are the same thing. So obviously, I know that I can multiply these two matrices together. So what do I have to do? I know that my resultant will be 2 by 1. So I'm sure I'm having a 2 by 1 matrix at the end. How do I multiply this together? One of the things I always tell you to do is that get the result out and try to bring like a model. What's a 2 by 1 matrix? A 2 by 1 matrix, we have something like this. So this is a 2 by 1 matrix. I know what the resultant will be. This is 2 by 1. All right. So I want to fill in this place. I want to fill in this place. Now recollect, if I'm going to say this particular where I'm touching right here, I will say this is row 1. This is row 1. And this is column 1. Row 1, column 1. So what I'm going to do is I'm going to go right here to where I see row 1. This is row 1 for the first matrix, and I will go for column 1 of the second matrix. So you can see I'm going to take this one and meet up with this to get this place. This will be 2 times 2 plus 4 times 3. That's what I'm going to use to solve here. For this other place, of course, this is row 1. Sorry, this is row 2, column 1. I'm going to go here to pick row 2, and I'm going to be picking column 1 here to fill in this place. That will be 3 times 2 plus 5 times 3. That's how I'm going to get right here. So that's the way you solve multiplication of matrix. Of course, this is just a revision class, so just to remind you of all these things. So let's go quickly into different types of matrices. We talk about something called the trace of a matrix. What do you understand? And if you can recall, what is the meaning of the trace of a matrix? We have a matrix A, and we're told to find the trace of that matrix. What are we talking about? What does it mean to have the trace of a matrix? So we have matrix A given as, let's say, minus 1, 3, 2, 1, 5, 6, 1, 5, 9. This is matrix A now, for instance. If we're told to find the trace of this matrix, we're told to find the trace of this matrix. How do we find the, sorry, this is me writing transpose. Or if this is A transpose, okay, I'll talk about transpose in a bit, but let me talk about the trace first. If we're told to find the trace of a matrix, how many of you can recollect what that means? What is the meaning of the trace of a matrix? The trace of a matrix, right? What do you understand by the trace of a matrix? Do you recollect? Okay, I see somebody saying addition of diagonals. Is it just any diagonal? Because recollect that we have several diagonals here. You can see this diagonal right here. This is a diagonal. This is another diagonal. Of course, if you talk about on top diagonals, these are 2 diagonals right here. So what diagonals are we adding together? It's not just any diagonal, right? Leading diagonal. Okay, I like that. Now, this is one diagonal, this is another diagonal. How do you know the leading diagonal in a matrix? The leading diagonal is obviously the one that stems from the left to the right. So this is the leading diagonal. That's how you find the trace of this matrix. The trace of a matrix is very simple to find. You just have to add up all the elements of the leading diagonal. That means in this case, I'll be having minus 1, which is the first element here, plus 1, then plus 9. This will give me a total of 9. All right. If you go on to do this other one, you'll be getting a wrong answer. So it's the leading diagonal. All right. Now, the other thing I talked about there, I said the transpose of a matrix. Let's talk quickly about the transpose of a matrix. Please hope I'm not too fast for anybody right here. I want to cover much topics. So I want to just do a bit of matrix, do a bit of trigonometry, a bit of every other one. So that's why I'm trying to be I want to be quite fast. If you can comprehend what I'm saying, please can you indicate that you are able to flow with what I'm saying? I'm not too fast. Please can you indicate if you're flowing with me, so I'm not being too fast for anyone. Okay, now you're not too far. Okay. Oh, okay, it's all right. So what's the transpose of a matrix? Very important point you must not forget. The transpose of a matrix is also, everything around matrix is simple. The major thing is just remembering what they mean. So when you talk about the transpose of a matrix, transpose, this is it written as A raised to the power of T. A transpose. So you have a matrix A. You're told to find A transpose. What do you have to do? What you really have to do is to just, we talk about the rows. You must know what the rows are. The rows is always the horizontal one. These are the rows. So the first row has minus 1, 3, 1, 2, 1, 5. The third row has 5, 6, 9. Those are the rows. If I say identify the columns, the first column is minus 1, 2, 5, 3, 1, 6.
the last column is 159. So what you want to do when you are dealing with the transpose is you want to change every of the rows. You want to make every of the rows become column. So wherever this is row 1 now, -131, you want to change that to the column. So look at it now. It's horizontal, but you're going to make it vertical. So it's going to be -131. You can see I've changed row 1. Oh, people say I'm too fast. Okay, let me try and okay. All right, let's take a deep breath and let's move to some people's understanding. So the row 1, this is row 1 now. I'm changing it to column 1. You can see the horizontal becomes the vertical. Now the next one is, this is row 2. I make it the next, you can see it was the second horizontal. Now I'm making it is the second vertical. All right. Now this is the third horizontal, which is the third row. I'm making it the third vertical. And that's how I'm able, this is exactly what you call the transpose of a matrix. So I've been able to convert this matrix A, and I've gotten its transpose. That's how you do the transpose of a matrix. It's that simple. All right, good. Now let's move on. Let's talk about something called singular matrix. When you talk about singular matrix, you cannot talk about singular matrix without talking about determinant of a matrix. So you need to know what determinant of a matrix is before you can be able to talk about singular matrix. Singular matrix. Now, when dealing with matrix, sometimes you will see a question being written as a non-singular matrix. The meaning of a non-singular matrix means a matrix that is not singular. So the question is, what's the meaning of a singular matrix? All right. A singular matrix is a matrix that has its determinant equals to 0. If you can recollect that. So for a singular matrix, you have the determinant of that matrix being 0. So if you're done solving the determinant of a matrix and you got the determinant to be 0, just know invariably that that matrix is a singular matrix. But any other matrix you solve and you do not get 0 as the answer, as the response for its determinant, that matrix is a non-singular matrix. So when they say a non-singular matrix, they can ask you questions around a non-singular matrix, meaning that if I wanted, let's say, let me give you a quite a trick question that can come out when dealing with singular and non-singular matrix. Let's say, for instance, I have -1, 3, x, 5. I said this is the matrix A. I now said matrix A is a singular matrix. I said A is singular. I now say find x. A is singular, find x. Do you know what that means? That means I'm invariably just saying this matrix, when you find the determinant, you get 0. So go on to find x. So you have to use your understanding of determinant of a matrix and your understanding of singularity of a matrix to be able to find the hex here. So what do I have to do? Of course, this is me revising determinant of a matrix. How do you find determinant of a matrix? Determinant of a matrix is basically just you multiplying the leading diagonal. The leading diagonal is always from left to right. All right, left to right. So left to right, this is the first diagonal, the leading diagonal. This is the other diagonal. So you multiply the leading diagonal and subtract the other diagonal from it. That means this would have been -1 times x minus 5 times 3. This would be minus x minus 15. Minus x minus 15. Good. Now, if this is minus x minus 15, this is the answer to the determinant. But I told you that this matrix is singular. That means I'm saying this result was equal to 0. That means the determinant, which is what I was finding here, was equal to 0. I said all these things was equal to 0. That means I know that minus x here is equal to 15, and I know that my x is equal to minus 15. Can you see how I've been able to get my x? I told you, I gave you a matrix. I left out one of the values. I said this is an unknown. And I went on to say the matrix is singular. If you do not know what singular matrix is, you will not be able to answer this question because you would not know that it meant that the determinant was 0. From here, you see, I'm able to find my x value. Does that make sense to anyone? I hope you guys are able to understand what I just said. All right. So what do you mean by a square matrix? A square matrix. Well, a square matrix. I'm just trying to revise all these basic concepts around matrix. A square matrix. A square matrix. Are you guys still there? Okay. I want to be sure I'm flowing with everyone. Hope I'm not too fast. A square matrix. A square matrix is actually a matrix that has the rows and column the same. So for instance, a 2 by 2 matrix, this is a square matrix. A 3 by 3 matrix, this is a square matrix. A 4 by 4 matrix, this is a square matrix, and so on and so forth. All right. All these are square matrices. So let's run quickly to what we call adjoint of a matrix. The adjoint of a matrix. Now, I must say this, even though this, what I solved there was the determinant of A, of course, let me remind you that when you say determinant, you can use DETA to represent it, or you can use this. That means A being in absolute values, in absolute brackets, absolute, not a bracket, this line bracket or whatever we call it. So this is how you see determinant being represented. Now, but what I want to say is that this is a 2 by 2 matrix. This is the way we solve the 2 by 2 matrix. I'm sure everybody here knows that it's not the same way you're going to solve a 3 by 3 matrix. So probably we'll just talk about that in like 2 seconds, because I think everybody should know that. Just to remind you before I go into adjoint of a matrix. Are you getting something? Hope I'm not. Hope you are reminded. The major thing for this class is just to remind you, not to explain in details, because we can't explain in details in this class. I want to make sure your memory is refreshed so that you are able to recollect all these things. Even though you don't have to read them again, you may not even have the opportunity. You want to, all these things you may not have the time to revise all these things, because I understand you guys are going through a lot, intense, all the many things you're going through, several things to do and everything. So this will just help you to recollect. So you may not have the time to revise it again, but at least you'll be reminded of this concept before entering the exam. So if I want to solve the determinant of this 3 by 3 matrix, is different from a 2 by 2 matrix. What do I have to do? There are two methods. The two methods is not use, but you don't have to always use this one. I'm writing, this is the matrix I'm trying to find the determinant now. The method I taught you is that if you want to use the second method, you will duplicate these first two columns. I'm sorry, write 1, -1, 3, 1, 2, 1, 5. Can you see that? I just duplicated column 1 and column 2. So what do I want to do next? What I want to do next is to bring out the diagonals. Can you see that? So now, having done this, of course, you know that the leading diagonal is always left to the right. So this is the leading diagonal. So you have 3 leading diagonals here. This is the first leading diagonal. This is the second leading diagonal. This is the third leading diagonal. So you want to multiply each of them together. So -1 times 1 times 9, plus 2 times 6 times 1, plus 5 times 3 times 5. You want to add them all together. You will get the first side, all right? So that will be for one side. Then minus, you get for whatever you do, this times this times this plus for the remaining 3, you will now subtract these other ones from it. 5 times 1 times 1 plus -1 times 6 times 5 plus 2 times 3 times 9. You put it right here. When you do your subtraction, you get your answer for your determinant. It's that simple. So of course, we may not have the opportunity of solving it because of time. Just a revision class. So if you have any issue in any of all these things, one thing you can do is that while you are watching, if you see that something is not very clear, probably you have forgotten it and you needed to practice, then you can highlight that somewhere in your jotter, and then after this class you can go on to quickly check it up. So that's one of the things this class will do for you, bringing out anything that you probably have forgotten. So, but the other method is quite, you just have plus, minus, plus written on the top, plus, minus, and you go on to write plus. Then after you write plus, you put a determinant something. Sorry, not just plus. You write plus minus 1 because you'll be picking the first. So you have plus minus 1. I know why I'm doing that. I'm doing it that way so that everyone can follow exactly what's going on. So I know that plus times minus is minus. I could have written minus 1 here, but if I wrote minus 1 here, somebody would not know that I actually added a plus. So the next thing I'll write is minus 2. Then I will put this also. Then I'll write the last one plus 5. And I'll put this also. That's the first step. So we have plus, you pick the first number there, plus of that number. I used you can see minus 1 was there, minus of the other number, then plus of the other number. So in this case, I know that this will be plus times minus, this return to minus. So I think everyone can follow that one perfectly. So I don't even have to put in bracket anymore. I can just write minus 1. Now, how do you fill in all these things? How do you fill them? Look at it right here. This is this minus 1. This first one was taken from row 1, column 1. So you isolate row 1 and that column 1, you isolate it. And then whatever is left, 1659, you put that here, 1659. All right. For this other one, minus 2. Minus 2 is actually seen in, it's still minus, this 2 is seen in still row 1, it's still seen in row 1, but also column 2. So the leftover, that's 3619. 3619. You fix them there. All right. And the last but not the least, that's plus 5. You can see plus 5 is still on row 1, but it's on column 3. So leftover is 3115. So this is what you're going to solve, basically, for you to get your answer. So you can see now, this means determinant. So you have to go find the determinant of these matrices, newly formed matrix inside this determinant bracket. So you go and find the determinant of this, find the determinant of this, find the determinant of this. And whatever you get as determinant, you multiply it with minus 1 in this case. Whatever you get as determinant here, you multiply with minus 2. Do the same thing here. Your final answer will be your determinant. So that's just basically how you find the determinant of a 3 by 3 matrix. Good. So let's run quickly to adjoint of a matrix. All right. What is adjoint of a matrix? In case you have forgotten, let's revise it quickly. So you have the adjoint of a matrix also is the same way you have different methods of solving determinant of a matrix. That means when dealing with determinant, you know, the way we solve determinant of a 2 by 2 matrix is different from the way you solve determinant of a 3 by 3 matrix. The same way it goes for the adjoint. Now I need you to understand that when solving determinant, you only solve determinant for a square matrix. That means a matrix where the rows and columns are the same thing. You can see you don't solve determinant of a 2 by 3 matrix, for instance, or for a 1 by 2 matrix. So the same thing goes for adjoint. So let's see how this works. Look at this matrix now. 2, 3, 5, minus 7, for instance. We have this matrix now. I said find adjoint. This is the way you talk about the adjoint. Let's say this is a matrix A. You say adjoint of A. This is how you write it. All right. Now, adjoint of A. How do you find the adjoint of A or matrix A? Very simple. You just need to remember and recollect the concept. Very, very simple. Adjoint of A. This is a 2 by 2 matrix. So I'm explaining the adjoint for a 2 by 2 matrix. It's different for a 3 by 3 matrix. We'll get into that in a bit. Look at this matrix now. This is the leading diagonal. This is the other diagonal. 2 minus 7 are the elements of the leading diagonal, whereas 3, 5 is the element of the 2 here. You can see that I just interchanged the element of the leading diagonal. I brought 2 to this where minus 7 was, and minus 7 to where 2 was. And then the last thing you want to do is that you want to change the sign of the other diagonal. So here I can see this is a plus 3. I'm going to change it obviously to minus 3. I can say this is minus 5. I'm going to change it to, sorry, this is plus 5. I'm going to change it to minus 5. This is the adjoint of the matrix. That's all. Literally everything. Let me see if you can try this one. Can you give me the adjoint of this matrix quickly? Let's say this is matrix B. Can you quickly give me this so that you people can test yourself quickly, so that you can try your hand on something? What's the adjoint of this matrix B? Oh yeah, let me get answers, so that at least you people are flowing. This is you can see this anywhere, and you should not forget it. It's very simple. What's the answer? What's my response? What's the response to this question? You want to find the adjoint of matrix B. What do you have to do? Oh yeah. We're moving fast. We have so much to cover. So what's my answer? What's the answer to this question? Anybody with an answer there? I thought I should be getting like 50 different responses at this time. Okay, if you're trying to find the adjoint of B, yeah, you're trying to find the adjoint of B, what you have to do is, obviously, as I said, you want to change this. Of course, you change 6 to where -2 was, and -2 to where 6 was, and you want to change the sign. So the sign now, this was 1 before, this returned to -1. This was -5 before, this returned to 5. That's all. That's the adjoint of matrix B. So simple, right? Good. Let's run quickly to that of a 3x3 matrix. So let's assume we won't be able to, obviously, as you can know, already, we won't be able to solve all the questions. We won't be able to solve the questions completely because of time. But if you know you have issues with solving them, you can go on to practice at the end of this class. This is just to bring to your memory the concept around it. All right. So now look at this matrix. I believe you should be able to see the element here. So let's say we want to find the adjoint of a 3x3 matrix. This one I wrote here is the adjoint of a 2x2. Is different. When solving 3x3, it's totally different. This one you have to pay more attention. This one is quite much more simpler than that of a 3x3. A 3x3 is a bit more. It comes with more patience. Now, I want you to know that when you are dealing with this, let's say this is matrix A. If you want to find the adjoint, please pay attention. You want to find the adjoint of somebody says she doesn't understand. Which part don't you understand? Is it swapping those things? Probably when this video is released again, you can go on to try and look at it. It's quite very simple. What I just explained is just swapping the element of the leading diagonal and changing the sign of the other diagonal. Now, look at this one now. Let me remind you that when you are finding the adjoint of a 3x3 matrix, okay, I see somebody talking about negative power. I can do that right in this class. No problem about that at all. If we can't do it today, we'll probably do it tomorrow. No problem. I would look into that. You want to know the binomial expansion of a negative power? No problem. So if you're trying to find the adjoint of A, please let me remind you of something. This is where students used to make mistakes. Adjoint of A is the cofactor transpose. When you go through a lot of processes here, because one of the things that happens is when you go through the process of finding the cofactor matrix here, sometimes many students get carried away and they go home feeling like that's going to be the adjoint. No. If you are not getting the cofactor matrix, you have to still transpose the cofactor matrix. So the very first step is for you to find out what the cofactor of this matrix A is. All right. I don't know. Is somebody complaining that you can't see all these things? Is it? Or are you sure it's not your network? Is anybody having the same complaint? You can't see what I'm writing. Is it a general complaint or just a person complaining? Please, I want us to give me a feedback. So I have this matrix A. I want to go on now to find a cofactor. All right. Sorry? Okay, you can see clearly. Okay, good. Probably it's the network of the other person. Now look at this matrix now. I want to find a cofactor of this matrix. What do I have to do? Very, very simple. Please look at the first step in case you are forgotten. It's different from the determinant of a 3x3 matrix. It's different because in this case, it's only the sign you'll be bringing out. You won't be bringing out the numbers associated. In determinant, we used to when we are using determinant, obviously, you used to say plus minus plus. We'll say plus minus plus. And then we'll bring out plus of this, minus of this, plus of this. Please, when dealing with adjoint of a matrix, trying to find a cofactor matrix, you don't want to, you're only interested in the signs. Now, another thing is that you don't just write plus minus plus for the first three. You continue writing it till the end. So you start from plus, you will go to minus, plus, the next one will be minus, then plus, next one will be minus, then plus, next one will be minus, then plus. That's the first step. That's the very first step. So now, again, I told you you're not going to be bringing out, you're only using the signs. This is what I just said meant. So let me write the cofactor matrix will actually follow the same order as the original matrix. So let me put the cofactor matrix here. Cofactor row 1, column 1, cofactor, the element of the cofactor row 1, column 2, cofactor row 1, column 3. This one cofactor row 2, column 1, cofactor row 2, column 2, cofactor row 2, column 3, cofactor row 3, column 1, cofactor 3, column 2, 3, column 3. So these are the different elements for the cofactor. So you have to go on now to find each of these elements, each of them. Now, good. Let's try and find each of them. I won't do it completely, as you probably can. I just want to show you the concept. So for C11 now, for the cofactor element C11, it's going to be, look at, the position is this place. You can see this is the position. And I see the sign there is plus. So I write plus. Then I will bring out my determinant braces. For cofactor 1, 2, cofactor 1, 2, the sign there is minus. So I will have minus, then I'll bring this out. Cofactor 1, 3, I can see it's a plus. Cofactor 1, 3 plus, I'll bring out this. Same thing goes for cofactor 2, 1. Cofactor 2, 1 is actually with minus. Please, can you notice that I'm not using minus 3 or anything? I just wrote the sign alone. That's what I'm trying to emphasize on. Cofactor 2, 2, we have plus there. You have to be very patient. This is where the best of the best students sometimes make mistakes, because this is not attributed to your intelligence. This is attributed to your patience and your ability to be calm. That's what will make you to get to, or not your intelligence. So you have to be very patient here. The best of the best students can make mistakes here. Now, you will bring all these things out. I stopped at C23, but of course, you know, when you are solving this, you have to bring out till C33. Now, what you want to do now is the same way you did for when you are dealing with the determinant. Look at it. For C11, this is it. This is the position for C11. C11, this position is row 1, column 1. I'm going to block all those different row 1 and column 1. I'm going to block it. So this is going to be isolated. This one now, as you're seeing, I'm going to isolate this and bring out the remnant. 1659 is what is left there. 1659. 1659. So let me just do randomly, because I cannot obviously do for everything. I will just go and do for another one. Let me do for C23, this last one here now. Let's say I wanted to do for C23. What am I going to do? C23 is row 2, column 3. So I'm going to block row 2 and column 3. Look at the remnant now. Minus 1, 2, minus 1, 1. Minus 1, 2, minus 1, 5. I would advise if you can use a pencil. If you are solving questions like you can use a pencil, so that, and if you are very accurate, because if you are distracted in the exam mode and you go and pick minus 1, 3, 1, where you're supposed to pick minus 1, minus 1, 5, you will be, your work will have errors, which will not be proper. So now, what do you go on to do? Of course, you can see this is determinant. So you want to go on to find the determinant of this. And don't forget, there's a sign in front of it. You need to go back and use that sign. So let's say, for instance, you got, after you fold this down, it's 9 minus 30. 9 minus 30 is what? Minus 21. So the answer is going to be plus, bracket, minus 21. So look at plus times minus is minus. The answer will be minus 21. So I already know that with what I have here, my C11 now will be minus 21. Let me do for this last one here, the C23. C23, of course, you go on to find the determinant here. Minus 1 times 5. That's minus 5 minus, this is minus 5. I'm trying to find the determinant. Minus 5 minus 1 times 2. That's minus 2. That's minus 5 minus 2. So that will be minus 5 plus 2. That will be minus 3. So the final answer I got for the determinant is minus 3. But don't forget, there is a minus in front here. So that will be minus times minus 3. Okay, it looks like you cannot see that. So my final answer was minus 3 when finding the determinant. But there is a minus in front here. So that will be minus times minus 3. This obviously will give me an answer of plus 3. So wherever I see C23 now, I can go on to write 3 there, plus 3 there. So can you see how I'm able to, that's the way you're going to feel for every other one. So when you're done filling for every other one, that's the way you're going to extract your cofactor matrix. Now, if you go on to write that as the adjoint, you will be wrong. And that's why you must remember and recollect that the adjoint of a matrix, of a 3 by 3 matrix, is the cofactors transpose. So when you're done finding the cofactor, you now need to transpose that cofactor. And I explained here in this class how to transpose a matrix. You will change the row to become column. So the horizontal becomes the vertical. So every of the horizontal, you place it into the vertical side of sides. So minus 2, minus 21, C11, C1, whatever was C13 will become on this side. And same thing goes for this one, become the second one, and so on and so forth. That's the way you're going to transpose the matrix. So when you're done transposing that matrix, that is now the adjoint of that matrix. Does that make sense? So this is all revision. So let's go quickly to what we call the inverse of a matrix. The inverse of a matrix. Okay, now let me just use this place. The inverse of a matrix, which is always where questions used to come out from. And let me tell you why questions do come out from the inverse of a matrix. It's because the inverse of a matrix, while you're preparing for an exam, you need to always look for aspects of that topic where you are able to be tested on various things, like multiple things in one. You know, I'm not even going to say 2 in 1 here because it's going to be more than, sometimes 3 in 1. It will be examining you on 3 different concepts in just one question. Those are the kind of questions you should be very careful of, because it's easier to examine you on that, knowing that they would have broadened their net to see your scope of knowledge. So if I ask you to find the inverse of a matrix, which is always written as A inverse, this is the way you write the inverse of a matrix. All right, A inverse. So if you see a question that said find, and they write A raised to the power minus 1, understand that what they're asking you to find there is the inverse of A. All right. So what is the inverse of any matrix? Any matrix, whatsoever the matrix is. The inverse of a matrix is the adjoint of the matrix over the determinant of the matrix. So can you said sometimes it's 2 in 1 question, sometimes it's 3 in 1, sometimes it's more than that. Look at it now. Me asking you to solve the inverse of a 3 by 3 matrix, I will be able to examine you on number 1, knowing how to find the determinant of a 3 by 3 matrix. Number 2, I'll be examining you on being able to find the adjoint of a matrix. And number 3, I'll be examining you on you recollecting and remembering the formula of the inverse of a matrix. So if you know how to find the determinant of a matrix, okay, good. If you know how to find the adjoint of a matrix, if you forgot the formula for the inverse of a matrix, of course, you will only get 2 out of 3. So that's why they want to ask you questions like this, because it covers 3 different aspects of matrices. So what you want to do when you are asked to find the inverse of a matrix, just go on to find the adjoint of that matrix, go on to find the determinant of a matrix and place them like this, and that's your answer. All right. I don't think we don't need to say much on that, because I believe you guys understand what exactly I just said. So let's go on to system of linear equation, which I believe is possibly the last aspect of matrix we'll be dealing with. So system of linear equation, it's a part of matrix where I hope you guys are flowing with me, because I'm just moving with intent. I want to see how to revise several topics. So that's why I'm kind of moving fast. Hope you are flowing. Please, can you indicate if you are flowing and you are recollecting everything I'm talking about, you are flowing with me? Can you please just give me a feedback quickly? So we want to talk about the systems system of linear equation. A very examinable part also. Very, very examinable part of matrix. This system of linear equation. What is system of linear equation? Look at it this way. When you were doing mathematics, we talk about simultaneous equation. When we have 5x, the meaning of simultaneous equation is very simple. That means two equations that are happening simultaneously. What is an equation? An equation is something that has an equal sign. Once you see something that has equals, like in this case now, this is an equation now. And this is another equation. All right. So these are two equations happening simultaneously. That's why we call it a simultaneous equation. Good. Now, we used to solve this kind of equation using several medium. Substitution, elimination, and all the likes. Graphical is also possible. But we can also use matrix to examine this and to get the answer. And that's why that's the topic, that's the concept that is called the system of linear equation under matrices. So what do you want to do when you have something like this? Now, this is the basic one. You can have that of three variables. This is obviously two variables. The two variables featured here is x and y. You can have three variables where you have x, y, and z. So, but here is a basic one. So look at the way you extract this out. Very simple. The first thing you have to do is to write the equation in matrix form, in matrix notation. How do you write this in matrix notation? Very simple. Take the coefficient of each of the variables. Look at this coefficient of x, 5. Coefficient of y is -3, or not 3, -3. Coefficient of x here again is 6. Coefficient of -2 of y is -2. Turn that to a matrix. Can you see that? So I turned this. This is the coefficient of my variables. This is it here, right here. This coefficient of the variables here. So I want to go on now to also put the variable side by side, this x, y. That's the second step. So I've extracted all the elements of this of the variables here. Then I put the variables themselves here. Now, if you go on now to, I explain how to multiply matrices. And if you go on to multiply these two matrices, you will get the same thing. This thing here, you will get it. This thing. If you go and multiply this matrix and this matrix, this is what you will get. So you see, we have been able to turn this from equation form to matrix form. Good. And the last but not the least thing you are going to do is to, of course, put the equals to and put the constant variable. These are constants. All right. They don't have any variable with them. Put them also here. So you can see that right now. So this is it. This is the first step. Being able to turn your variables, your equation to matrix notation. So now what's the next thing to do, guys? I don't have much time here to dwell too much on this. This is a revision class, but let me remind you of this. We can call this anything. We can name these three matrices anything, but I think I love to always write this as A, small letter X, and B. Right? This is the way I like to name them. So you can name them anything you want to, but this is my own nomenclature. So I named this matrix, the one that was the coefficient of the variables, as matrix A. I named the variable matrix as matrix X, and I named the constant, the matrix that has the constant values, as matrix B. Good. So that means we have A times X equals to B. Now I don't want to go into the way why this is this way. I can explain that, but because of time, let me just tell you what you are supposed to do. What you're supposed to do here is to go on to multiply each of these matrices. I want to, this is my matrix of interest. I want you to know that if they say solve this equation, guys, what do you mean by solving an equation? Anywhere you see, anywhere on any topic that you see them asking you to solve, just understand that they're asking you to find the unknowns. The unknowns here is X and Y. So that means X, because this is the unknown, your variables, which is what you're looking for. So obviously, when you have A times X equals to B, you should understand already that it is this X that is the matrix of interest. So you want to find a way to isolate this so that you can have order of your matrices, bringing out the result. So if I want to isolate this now, using the best way to do this, using matrix operation, is to multiply This is the best way to do it. You see, I multiply matrix A with the inverse of A. I multiply matrix B with the inverse of A. That means I multiply both sides with matrix A inverse. Now, you know what this gives me? I don't know if you recollect this. A inverse times A is equals to identity matrix. So that means A inverse times A. Please don't misunderstand this. This is not algebra. This is matrix. So A inverse times A is obviously identity matrix right here. So this is identity matrix times X will be A inverse times B. So an identity matrix times anything is the matrix. I think I've told you that before. That identity always has like, if I say identity times U, it would be U. Identity times A will be A. Identity times X will be X. So obviously this will be X. So X here will be equals to A inverse times B. So this is what you have to do in order for you to get the answer here. So for me to get this answer right here, this particular answer for this place, I will need to go and say my X matrix will be equals to A inverse times B. So this means I want to go and find the inverse of this matrix A. Can you imagine? Do you understand why this is a question they want to ask you? Like, why do you think they don't want to ask you a question like this? This question brings out a multiple scope of understanding for you to be able to solve it. You need to know how to bring all this notation out. You need to know how to get the matrix X. Then you also need to know how to find the inverse of a matrix. And you need to know how to multiply two matrices together. Because after finding the inverse of this matrix, of course, the inverse of this matrix should be the adjoint of A over the determinant of A. You go and find that somewhere. So after you get that and you get an answer, you will now multiply that answer of A inverse with this matrix B. And that will bring out the result. So that's just it. That's the reason why everybody wants to ask you a question on system of linear equation, because it produces it brings out the, good students from the bad ones, because anyone that doesn't know how to do the basic things can't solve it. So let me just use this to quickly revise the three aspects of it, which is the kind of ones you should be expecting. This one is very simple. The 2 by 2 matrix, this one brought out this system of linear equation of two variables is very simple, because you are dealing with 2 by 2 matrix, and finding the inverse of a 2 by 2 matrix is very simple, because you have to just find the adjoint of a 2 by 2 matrix, and the adjoint of a 2 by 2 matrix is very easy. That's the one where you just have to change the leading diagonals element and then change the sign of the other one. That's very easy. So people, you know that if you're preparing for an exam, an A-level exam, you don't want to hook your understanding to just that, limit your understanding to just that one, because nobody wants to really ask you that of two variables, because two variables is easy to solve. What they want to ask you is that of a three variables, where you're having something like this: 3x minus 7y plus z, plus z equals to minus 1, 4x plus 2y minus 7z equals to 8, and 6x plus 9y plus 3z equals to minus 9. Now, I just want to bring this up so that you guys can adjust. This is a revision, don't forget. If they don't give you anything here, if I just write this and I stop here, I'm sure you will understand what this means. If I just wrote the last expression, I wrote 6x plus 9y equals to minus 9. I hope nobody is there feeling, oh, this is going to be a wrong question. It's not a wrong question. What happens there is just like what you have is plus 0z. That's just the meaning of that. So the coefficient of z for this last one will be 0, which is possible in matrix. I'm sure you know matrix can have element of 0. You can have 0 in some of the elements. So that's, just understand that. So you are not just, probably I just write, let me write it like this. Let me use this one as an example so that you can flow very well with this one. I know you can flow. If it was something that, if I play something, I'm sure you guys can flow with that. So let me try and put it as this. So look at what's going on here. If I want to bring out, of course, the same steps is what you will follow. You go on to bring out all the elements. This will be 3, 4, 6, minus 7. I'm sure you can flow with me now because we already did one already. And then this will be 1, because this is just z, minus 7, and then this will be 0. All right. So this is your This is your matrix, the coefficient of your variables right here. And you go on to fix the x, y, z this way. And then you go on to fix the constant, -1, 8, -9. All right. Now, again, I'm going to name this matrix the same way I used to name it. This is my own, or you can name it your own. AX, B. Don't say, why do I name it X? Why do I name it B? It's just nomenclature, right? So now, the same way you did this same thing we apply. X here, for you to find the X here, and don't forget, finding X will mean you are finding the values for X, Y, and Z. So your X, by the way, if you find your matrix X, you must always get your matrices as answers like this. Maybe -1, -2, 4. It will be the same way X was, the same way this matrix X was, the same way this matrix X was. That's the same way it's going to come out. You cannot be getting your X as a 2x3 matrix or anything other than this form. Means you have done something wrong. Your X must come out in this form, something like this. I'm not saying this is the answer. I'm just saying something like this form must be your final answer when you find your X. All right. So what you have to do here, obviously, is to go on to find the inverse of this matrix A, which is what you can see right here, the inverse of this matrix, and then multiply whatever the inverse is with matrix B. So I'm sure everybody can relate to why they want to ask you a question like this, because the inverse of a matrix A in this case is much more tougher to solve than that of a 2x2 matrix, like the previous one we just did. So obviously you want to prepare for questions like this. So in this case now, for you to find the inverse of this matrix, you want to go on to find the adjoint of the matrix first, then find the determinant of the matrix, then find adjoint over determinant, which is the inverse. So, and the adjoint of this matrix, don't forget, I just explained it. You have to find the cofactor, and then you have to transpose the cofactor. That's where you find the adjoint. So you can see why this is a question of interest when preparing for a Jupeb question. All right. Now, somebody is asking about Cramer's rule. Cramer's rule works very fine. All right. You can use Cramer's rule. What is Cramer's rule? Let me remind you guys. I don't know this. I believe we did this. So, what is Cramer's rule? This is method. This is using matrix method. Please, if they ask you to use this method, please make sure you stick to this method. This method is very simple. It's just arranging it in this form, then going on to find, in this case now, to find your x now will be A inverse times B. It's very simple. You go and find it. If you can find the inverse of a matrix, go on and find the inverse of this matrix A, and then multiply that inverse with this B, constant value B, constant matrix B. If the matrix that contain your constant element, and that's all, you get your answer. It's very simple. There's nothing difficult about that at all. But for Cramer's rule, for you to be able to solve using Cramer's rule, you have to really understand determinant very well. You have to understand. Sorry, somebody's talking about finishing the matrix. Finishing the matrix in what form? Like, you want me to solve it? I'm not sure we have the time to solve it, if that's what you mean, bit of time. I would advise you to probably just, we have a video on this already, probably go and watch that up, so that there's if you want, you can give me a chat, and let me help you with how to go on with that, so that we just don't waste too much time. I may not be able to solve in perfection, you know why already. We want to cover much topic. So now I want to explain Cramer's rule. For somebody that talked about Cramer's rule, you can use Cramer's rule, but you have to really know your determinant properly. So let's bring out this whole matrix. Look at for you to use Cramer's rule. Look at how you use Cramer's rule. I go on to bring out 3. I'm bringing out all the. Look at what I'm going to do. Please pay attention. -7 to 9. Then I have 1 -7 0. Now just put something like this, and then put -1 8 and -9. All right. Now this is, you can look at what I just did here. This is the matrix that came out from this side of things, the left hand side. This is the matrix that came out from the right hand side, the constant, the one that are constant values. So when you want to use Cramer's rule is very simple, but you need to be very you need to pay attention to the method. So I want to find x, y, and z. So for you to find x, you will have to go on to find look at the way I'm going to write it. Determinant of matrix X, I'm going to write it this way, over the general determinant. For you to find out of Y, determinant of matrix Y over general determinant. And this is me just naming this. And determinant of matrix Z over normal determinant. This is the last thing we are doing on matrix, all right? So now, how do I say general determinant? This general determinant is this normal matrix. Look at this normal matrix I boxed up right here. You go on to find the determinant of this matrix I boxed up. That's what we'll call the general determinant. When we find the determinant there, we'll call it the general determinant. Now, we now need to go, after you find the general determinant, maybe you got it to be maybe 18, for instance. Let's say you got it to be 18. So that means everywhere right here, you'll be having over 18, over 18, over 18. That's for the general determinant. You now need to form new matrices, which we'll call matrix X, matrix Y, matrix Z. How do we form those matrices? Look at, you can see 3, 4, 6 represents the coefficient of your x's. You can see it right, 3, 4, 6, 3, 4, 6. It represents the coefficient of your x's. What you have to do to make your matrix X come out is that you will substitute all these coefficients that has to do with your X. You substitute it with the constant value. So you will build up a new matrix. This is how, look at the way the new matrix will look like. I'm going to maintain my other matrices. Look at my other columns. I'm maintaining the column for Y, the column for X, for Z. I'm maintaining both of them. All right. I'm maintaining both of them. Can you see that? Maintaining that of Y, maintaining that of Z. But you see this one for X, 3, 4, 6. I'm going to remove everything and replace it with the constant aspect. So I'm going to change this to -1, 8, and -9. This is what I will call the matrix that will give me my determinant for my matrix X. So if I go on to now find the determinant of this, let's say I got it to be 36. Let's say I got this. Let's say I got this one now. I found the determinant of this one, this matrix. I found the determinant to be 36. Then I found this one. Let's say I found the general determinant to be, when I did not remove anything, I found it to be 18. So I will now go on to say my X is equals to 36 over 18. That will be 2. I'm not saying this is correct, though. I'm not saying what I did here is 36. I'm not saying these things are 36. I'm not saying it's 18. I'm just giving you a sample. All right. Now, that's for my matrix X. For this Y, if I wanted to solve for Y, don't forget, it was the X column that I removed. So I have to go on to form Y now. What I will do is that I will maintain the X, because if I'm doing for Y, I will maintain the X. X will be the same thing as what it was normally. It's that of Y I will now remove and replace with the constant. So I'll replace it with -1, 8, and -9. You can see that. So that's how you find the matrix Y. So I will get the determinant of this matrix. Now, the last one now, that for Z, will be that I will maintain for X, I'll maintain for Y. Then it is that of Z I'll replace it with the constant something. Then I'll go on to find the determinant of this. So if I go on to find the determinant of this, then I will now be able to find my determinant of Z. So whatever I get there, I'll divide it with the general determinant. So that's basically what Cramal's rule is all about. Does that make sense to everybody? So I didn't, of course, you can use any of the method. If they are silent on which method to use, if they emphasize you should use Cramal's, then you have to use Cramal's. If they emphasize you have to use matrix method, this is matrix method, the one I explained to you before. So that's just that about that. All right. So guys, let's run into trigonometry very quickly. Let me give you quite a bit of revision around that. I'm sure you can see that we are moving very fast, and still that's why I said we have to just keep moving. There is a lot to talk about. I really want to do some revision on conic section. I really want to do revision on conic section, because you are going to see conic section, by the way, in your exam. I want to do revision on conic section. I want to do revision on binomial expansion and many others, but we just have to keep moving. All right. So let's keep moving. So guys, how do you feel about matrix now? Are you reminded of all these things? Do you feel a bit refreshed in the knowledge? Let's run quickly to trig. All right. Now, I was explaining trig to a young guy last week or this week, and as I always said, your trig, whatever will help you, whatever will lead you to succeed in trig, will be embedded on something called identities. Know your identities, you know peace when solving trigonometry. If you have issues with collecting your identities, I can assure you there are going to be so much issues. Now, I want to, there are some things I will just point out while revising trig because we'll just solve very few questions. We can't solve too many. So now, look at trigonometry. One of the important things on trigonometry is identities. The second one is understanding the concept of angle of any magnitude. See, if you know these two things perfectly, you can bring all your identities out. You know all your identities, and you know angle of any magnitude. I don't see you missing any question on trigonometry. I just don't see it. It's literally not possible. But when you have issues with identities, you can't even know a pathway to move through. That's why many of you are always a bit confused when you see questions, because when you don't know the identities, you don't know what to write there. Now, let me quickly revise on identities. I won't solve so many questions as you know already, but let's say, for instance, we have sec squared theta equals to tan theta plus 1. Let me just write 7 here so that it looks like the one we even have in our notes. Look at this right now. For a student that doesn't understand the identities, this question looks very strange. Strange because we have sec theta. This is a trigonometry ratio here, sec theta. This is another trigonometry ratio here, tan theta. How do you bring these two together? So many people feel these questions are so tough. Of course, it's going to be tough if you don't know your identities. But if you do know your identities, you cannot have issues with this at all. All right? Now, look at your basic identities, where I'm going to bring out my questions from. And I want to quickly say some things. There's some things I want to mention about the identity, especially the basic ones. I want you to know how to manipulate yourself around trig. You need to be very good at manipulating yourself in trig. When you're solving trig, you don't solve trig with logic. You solve trig with manipulations. That means you know where you're going to. So you'll be using all the identities to move towards somewhere. That's the whole concept. So look at something. We have the first identity, which is the basic one. That tan theta is what? Sin theta over cos theta. Let me quickly say one thing now. Do you know that I can write my tan squared theta to be sin squared theta over cos squared theta? Yeah, that's some things you just need to hold on to. You don't have to be rigid. If you see something that requires you to move this, of course, since you know that tan theta is equal to sin theta over cos theta, this will work. All right, this is one of the first trig. Of course, we said basic trig doesn't mean that we cannot bring out more things from them. It just meant that those are basic. From those ones, we can now go on to establish other points. Look at also another important trig, very important. This one, I don't even know if there's anybody that doesn't know this one. This one. This is another trig. Now, before I go on again, let me quickly say something. Some of you guys are not very used to knowing how to apply this theta. A, B. Some of you are just too rigid that you just feel this. The meaning of theta here means an angle. So the tan of an angle is sine of the angle over the cos of the angle. This could be tan A. If this was tan A, if the question they told you was tan A, you need to go on to write sine A over cos A, no longer tan theta, sine theta over cos theta. You need to remember that. Now, this is another trigonometry. Now, look at it. Now, you may not always see a place where you'll be seeing sine theta, sine squared theta over cos squared plus, sorry. You may not always see a question that will bring out sine squared theta plus cos squared theta. You may see a question that will only require, like, let me give you an instance here. Let's say we have sine squared theta equals to cos theta minus 3. Look at this question right here now. Of course, I do not see sine squared theta plus cos squared theta. I don't see that here. But one thing I know that I can use this for, the whole concept of trigonometry equations is that when you see a trigonometry equation, this is an example of trigonometry equation, this is another trigonometry equation. When you see those trigonometry equations, one thing you want to always recollect is that your aim is to try and bring all the equation in such a way that you are seeing only, as much as you can, only one trigonometry ratio. That means it's either you change everything to have sec theta. Of course, please don't forget, it can be sec. If I see sec square theta, if I see sec theta in the same equation, it's still the same, it's still okay. But I don't want to be seeing like cot theta now. I don't want to be seeing tan theta. I don't want to see sin theta. I only want to see one. Is either I'm changing everything to just see sec theta, or I want to see tan theta. Anyone that works for you, just do it. All right. Look at this question I wrote here. I see sine square theta equals to cos theta minus 3. You can't go further if you don't make everything one trig ratio. You have to bring all these things to one trigonometry ratio. Which one looks more convenient? I have a trig identity. Sine square theta plus cos square theta equals to 1. I can see it right here. What do I want to do next? If I go on to say sine square theta equals to 1 minus cos square theta, have I cheated? No, I have not, because this is based on this expression. This is mathematical. I can go on to say sine square theta is equals to 1 minus cos square theta. It's okay. I'm good. I have not done anything wrong. So now look at what I wrote here. I can now go on to say, rather than writing sine square theta here, I want to go on to write 1 minus cos square theta. Because look at what this has done for me now. You can see now that by changing sine square theta to 1 minus cos square theta, I have been able to throw away the site of sine theta. Now all I can see now is just, of course, this 1 minus cos square theta equals to cos theta minus 3. Now from this one now, I have a pathway forward. That's the reason why you need your identities. But let's imagine you do not know this identity here. If you don't know this identity here, there's no way you want to be able to convert sine square theta to 1 minus cos square theta. So, and once you are done doing this, then you go on moving in any other mathematical way you have. So now, this is another identity I've written here. Some other identities which you need to recollect is that of the, for instance, we are dealing with, say, sec theta, cot theta, cosec theta. Please note that cosec theta can also be written as CSC theta. So don't get yourself hooked up in anything. They are the same thing. All right. Now, sec theta is 1 over cos theta. Cot theta, COT, is 1 over tan theta. That's the cotangent, is 1 over the tangent. Secant is 1 over the cos, the cosine. Now, the cosecant is 1 over the sine of an angle. All right. These are basic identities you should not forget. Now, let me tell you a way you can always apply these things, because you need to use whatever you have to get what you don't have. If I see a question and I have sine sec square theta, pay attention, and I see that I'm having cos theta there, and it's also fine if I write it as this. I want you to know that this is also correct. That sec square theta is also 1 over cos square theta. So sec square theta here is the same thing as this. This is, I can also, this is perfect. This is okay. All right. So all I'm saying here is I know how to manipulate yourself to get to where you are going to. So I have been able to write 1, 2, 3, 4, 5. We have 2 more important identities I want to write out. I mean the basic identities. Now, don't forget we have something called cosec square theta. This one is another identity equals to 1 plus cot square theta. This is an identity you also have to note. This is the 6th one. Cosec square theta is 1 plus cot square theta. Never forget that. Very, very important identity. Also, we have sec square theta. is equals to 1 plus tan square theta. This is the last one, the seventh one. So we have 7 basic identities that I wrote for you, and you can see them all littered here. 1, 2, 3, 4, 5, 6, 7. This is the first initial 7. Now, I don't need to do so much here because we know we can't solve too many questions. This is just revision. You have to know all these things offhand. You need to be able to recollect them so that it becomes useful for you. Look at this question I have here now. 7 sec square theta equals to tan theta plus 1. If I see a question like this, what do I want to do? What I want to do is to recollect, because look at it. You don't like to see sec theta and tan theta in the same expression. It doesn't make so much sense. So what you want to do is to bring everything to 1. Any one you choose, it's okay. Just make sure you're only seeing one trig ratio. What is the identity that I know can help me to change this? This is the identity I wrote last year. Sec square theta is 1 plus tan square theta. So instead of writing sec square theta here now, I can go on to substitute that for 1 plus tan square theta. You say, why did I use this? I use this because I can see that this gives me tan theta here. I've been able to eliminate sec theta, and I also have tan theta here. So I've been able to, I'm having just one ratio. I'm dealing with just one ratio here. So look at it now. Now, after substituting the right way, you now need to express it mathematically. So I want to open all these things. This will be 7 plus 7. Now, it will be so sad that a student recollects all his identity, but is not able to solve all these things mathematically. For instance, he doesn't open this bracket properly, or he doesn't use the bracket when you wanted to write 1 plus tan square theta. Once you're writing a compound expression, always use your bracket so that whatever you are dealing with is penalizing everything inside, not just one of it or none of it. So this will be equals to tan theta plus 1. You can see how the way I'm able to bring all these things out. Now, look at something now. This is the next point I want to make before I'll be going into angle of any magnitude in a moment now, which is a very vital place of under trigonometry. You see, now after getting here, you need to look at something. You know what quadratic expression is. You know what quadratic equations are. By looking at this expression, I can see that this leads majorly to a quadratic expression. That means I can see already that I'm having, if I arrange this properly, I'll be having 7 tan square theta. I bring this here, minus tan theta, then let's say plus 7, because this is plus 7, then minus 1 equals to 0. Can you see that? You know what? You know how quadratic expressions are. They start from the power of 2. Quadratic means the highest power of the variable there will be 2. So you can see now we have tan square theta. Of course, you know tan square theta is the same thing as tan theta all square. So this is 7 tan square theta. The highest power here is 2. And then you have tan theta. Of course, you know how quadratic expressions are. If you have quadratic expressions, you want to have something like maybe x squared minus 3x plus 2 equals to 0. This is a quadratic expression. Are you not seeing that it's taking this form now? We have square, we have raised to power 1, we have a constant. So this obviously looks very much like quadratic expression. But what do we need to do next? I can solve directly like this, but because we are communicating with people that are just getting into this, sometimes the best thing to do is to try and substitute our tan theta for x. So we'll say let tan theta equals to x or y or p or anything or z. The reason for that is so that it looks much better, familiar. You are more familiar with what you are seeing. So look at what we have here. This will be 7 tan square theta is, I told you, the same thing as tan theta all square. So if you say x, that means you put x all square. That will be 7x. That will be 7x squared minus, of course, tan theta is x minus x plus 6 equals to 0. So looking at this right now, you have been able to achieve a quadratic expression. Now, this quadratic expression now is now something you now need to deal with your normal understanding of quadratic expression, which you now need to go on to use your either factorization method, completing the square, or formula method, whichever method you want to use, you need to go on to use it and arrive at an answer. Of course, you always have two answers or sometimes a double answer. Maybe x equals to -1/2 or 1, or x equals to 2 twice. It can also happen in any way. You need to just let the chips fall where they may. You don't need to try to get anywhere when you are here. You move normally. Now, let's just pause this for a moment. I want to quickly come to angle of any magnitude. This is where students get wrong answers. The fact that, okay, I don't know, is this thing solvable using factorization? Did you get an answer? Because I made up that question. I'm not sure if it's solvable or not. But I just wanted you to express how to always deal with quadratic expressions. Trigonometric expressions. I want to run to angle of any magnitude, and we'll come back here. So keep in mind on where we stopped at here. If somebody got this answer, can you tell me the answer so I can be very exact? But all what I wrote here, x being equals to -1 or 2, sorry, -1 or over 2 or 1, it's all a dummy answer. I did not solve that, all right? So if you have a correct answer there, you can tell me. But let me come quickly to angle of any magnitude and explain something very important there. For those of you that have forgotten this, very, very important aspect. See, angle of any magnitude is an aspect of trigonometry where you have to be very knowledgeable on if you don't want to go wrong. You need to remember and recollect your quadrants. Your quadrant is very key to solving angle of any magnitude. The meaning of angle of any magnitude is that you do not want to just achieve one answer. And that's why questions like this will say, what are the answers between the angles between 0 and 360? Whose sine is, okay, let me even start from there. Determine the angle between 0 degree and 360 degree. Whose sine is, let me write the first one. The first question will be 0.4658, just a dummy question. The minus 0.3216. Let's try and solve this to recollect angle of any magnitude. Then you will come back to this expression and I will tell you why this is very important there. Now, when you see questions with things like this, or they ask you to solve a question on that trigonometry in this level, in A level, please, I want you to know one thing. You are not supposed to just get one answer. You're supposed to determine all the angles. And how do you determine all the angles? You have to know your quadrants. Let's recollect what quadrants are. Quadrants, the meaning of quadrant means we have 4 different sections. And this first section, we are moving clockwise from the first one here. You can see where I first wrote my A. All students takes calculus. All students take calculus, or add sugar to coffee, whichever one you prefer. Now, what does this mean? This means all angles are positive. This means sine is positive. This means tan is positive. This means cosine is positive. Now, but let me quickly tell you one thing. Even though I said sine is positive here, don't forget, do you remember when we were talking about trigonometry identities? I told you that cosec, do you remember that cosec theta is 1 over sine theta? That means if cosec is 1 over sine theta, in this quadrant also, cosec is also positive. And don't forget, I told you that cot theta is 1 over tan theta. That means cot is also positive in the third quadrant. And I told you that sec theta is 1 over cos theta. That means sec is also positive here. So don't forget that so that you are not hooked up. Now, these are all the positive ones we are highlighting. All right? All being positive, sine being positive, tan being positive, cosine being positive. The meaning of this invariably is that every other one are negative. That means any other thing apart from these two now, sine and cosec, it's all negative. That means in this quadrant 2, sorry, let me label this. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right? Now, for quadrant 2 now, if sine is positive, this means cosine and tangent are negative in quadrant 2. if tan is positive in quadrant 3, that means sine and cos is negative here. If cosine is positive in quadrant 4, that means sine and tangent is negative here. Remember that. Now, let's get right to work now. When you're given a question like this, and you're told to determine the angles between 0 and 360, whose sine is this? The first thing you want to write is to try and interpret that mathematically. And always remember that you can always have questions in such a way that sometimes you may need to be very smart. All right. So the meaning of this, they said, determine the angles whose sine is, that means the sine of an angle is equals to, that's the meaning of this question, is 0.4658. Now, they say you should determine all the angles between 0 and 360, whose sine is this. If you're not aware of this aspect of trigonometry, what you want to do is to go on to say, you want to go on and say theta equals to arc sine this, and say my answer is that, and you leave. But that would be very wrong, because that's not the way you solve it in this particular aspect. What you want to do, the first thing you want to say is this. Look at it. Please pay attention. Whose sine is this? What is the sine? This, I don't mean sine now. I don't mean trigonometry ratio. What is it plus or negative? I said this is obviously a plus sign here. Now, you will ask yourself, where is sine positive? Where is sine positive on this quadrant? Where is sine positive? Okay, look at on this quadrant now. I can see that sine is positive in the first quadrant and sine is positive in the second quadrant. So what I want to quickly go and write is the two quadrants of interest. That's quadrant 1 and quadrant 2. This is where my result must come out from. Anything you are doing, this must be where your result comes out from. These two things will determine your final result. Now, I forgot to, not really that I forgot, but I have not written the function in here. Inside quadrant 2, we have 180 minus theta. Inside quadrant 3, we have theta plus 180. Inside quadrant 4, we have 360 minus theta. All right, good. So that means in this place now, quadrant 2, I have 180 minus theta happening there. This quadrant 1 is just default. So what this theta we have here now, this theta that is here, how are we going to get this theta? So how are we going to get this theta? We have to just come back. So this is what I will do. I will now go on to say sine theta equals to this. So I will now say this theta, my theta, is equals to arc sine 0.4658. Now, if this was minus here, I would ignore it. I would just go on to solve this. I don't know whatever this gave me. Let me have a calculator right here. Let me just write 54. And my theta here was 54. Now, what quadrant? Once you have quadrant 1 being featured here, you will just go on to write your first answer 54 degree, because quadrant 1 is always going to take whatever your final answer was here. And then for this quadrant 2, you go on to say 180 minus 54, and that will give you whatever you got. All right, that's the way you solve it. So these two results that you got here are the two answers. So the thing now is, I know this one is quite basic and simple. Let me go do for that of the negative, which is where I think some of you may have some issues. So the angles between 0 and 360, whose sine is minus 0.3216, for instance now. So you have to ask yourself, where is sine negative? Where is sine negative? That's the first thing you ask yourself. Sine is negative in quadrant 3 and quadrant 4. Of course, as we just approved, quadrant 3 and quadrant 4. And I know that the rules that follows this is theta plus 180, and we have 360 minus theta. See, these two things are what are going to bring out your final answer. These two things here, you're going to bring out your final answer. Whatever answer you get outside these two things is not your answer. The answer must be brought out from these two things, because that's where your sign is negative. Now, for you to know what this theta is, this theta here, you have to go on to do that thing I said you should do again. So you go on to say theta equals to arc sine. Now, you will ignore the sign there, you just do this. So arc sine this. So let's say you got your answer to be 32, for instance. I did not say that's the answer, I'm just saying for instance. So you go on to say, you use this 32 now to get your final answer. You put this 32 as your theta. That will be 32 plus 180. That will be 360. minus 32. Whatever answer you get for these two will be your final answers. That's the way this thing works. Now, some of the places where some of you may get confused again is that if you see them writing maybe y or he or gamma or beta instead of theta, just follow the same principle. If they change the nomenclature of the angle from theta to any other thing, just follow the same principle. All right. So this is what I'm going to say about trigonometry, because I feel generally that the major thing around trigonometry is your identities. So I don't know, is there anybody there having any question? Okay, I think I have. Let me try and see if I can solve one. Just give you a hang of one technical question right here. And let me see. Do we have any question? Anybody there having a question or having something you don't understand? Let me see. What are the feedbacks? Are you able to recollect all these things? Look at this question we have right here now. I don't know what's your feedback. Can you give? I don't know what was your feedback. Did I get any feedback from anybody? How do you feel about trigonometry? The identity part. Yeah, the identity. Oh, by the way, I just wrote the basic identities. There are several other identities I've written for you. We have the compound angle identity. We have the double angle. We have the sum and difference formula where you have situations where you are dealing with when you're dealing with sine c. I don't know if you can recollect this. The aspect that has to do with sum and difference. This is all in your notes, I guess. Is there anybody that doesn't have this in the notes? I think you all have this in the notes. So you have, just to remind you, I hope you have this somewhere. You have sine c plus sine d. What is equals to 2 sine c plus d over cos c minus d over 2. This is all identity. You also have the one for minus. If you have, this is the first one. If you have sine c minus sine d, of course this will be equals to 2 cos. Look at the difference. So this one was 2 sine. This one is 2 cos c plus d over 2 sine c minus d over 2. So an example quickly is a case where you imagine you have sine 6x minus sine 2x. Now, let's say you have a question like this, sine 6x minus sine 2x. Of course, you just need to apply this identity quickly. You can see now that your c here is 6x. This is your c. And your d is 2x. So you apply this identity, that will be obviously 2 cos 6x plus 2x over 2. That will be 8x over 2. Then sine 6x minus 2x, because this is 2x. That will be 4x over 2. So the final answer will obviously be 2 cos 4x sine 2x. Are you seeing that? So if you are asked to solve the question we have right here now, this sine 6x minus 2x, if you don't know this identity, there's going to be serious issues, right? That's why I said you have to cram all these identities. You have to just know them. All right. So this is how you solve questions around identity. Once you have deficiency with knowing your identities, you will have issues with trigonometry. There's no way around that, all right? There's no way around it. Your identities plays a very key role. Like for instance, if you look at your identities also, this is double angle now. You have to just cram all these things. And the best way to cram is to rewrite them or reuse them. Just keep using them over and over again. So when you use them several times, you get very used to them. There is one aspect of trig identities also that I've given you. For instance, if we have sine 2a or sine 2 theta or anything, it could be sine 2 theta, this is what we call double angle. So double angle in trigonometry is given as 2 sine a cos a. This is an identity now. This is all of them. This is an identity. So if you don't know this, there is going to be a serious issue. So if it was sine 2 theta, you are using it to be 2 sine theta cos theta, whatever the nomenclature of the angle, you just follow through. Same thing goes for cos 2a. Cos 2a now, what we have in cos 2a, we have it as cos square a minus sine square a. I don't know if you remember this. This is an identity also. This is an identity also. It's not something you have to be racking your brain on. Once you know it, of course, I explained to you how to get these things. But of course, I don't expect you to always prove them let's say you want to use cos 2a and you have to go on to be proving cos 2a. You will waste a lot of precious time in the exam. So that's why I just told you the best way is for you to cram it up. Now, this one I wrote now as cos 2a. I'm sure you know that we can also write it in different forms because obviously, if you recollect, you will know that sine square a plus cos square a is equals to 1. So if sine square a plus cos square a equals to 1, that means I can write this thing in two different forms where I will just re-express it only in one of the trigonometry ratio. For instance, I'm decided to express this cos 2a as only cos. Like if I want to express it as only cos now, I will go on to substitute my sine square a to be 1 minus cos square a. So that means if I wanted to write it as only cos, I'll be writing this as cos 2a will be equal to, now I'll be having cos square a minus, instead of writing a, now I'll be writing, look at it, you see what I did immediately? I opened a bracket. Whenever you're using a complex or compound expression, always use your bracket, minus cos square a. And see what I did there? So I'll be having cos square a minus 1 plus cos square a. Cos square a plus cos square a will be 2 cos square a minus 1. You can see. So you can write it this way. You can write it this way. You can also decide to write it in terms of only sine square a. And in that case, that means I'll be substituting my cos square a for 1 minus sine square a. So wherever I see cos square a now, instead of writing cos square a, I'll be writing 1 minus sine square a. So that way I'll be able to re-express everything in terms of sine square a. So we have cos 2a equals to, now I'll be having 1 minus sine square a. You can see instead of writing cos square a, now I'm writing this minus sine square a. So this will be 1 minus sine square a minus sine square a, which will be 1 minus 2 sine square a. Are you seeing that? By the way, I'm seeing that I could even come from here and just write. I didn't say you should follow me. This is just me enjoying myself right here. 2 minus 2 sine square a minus 1. This is 1 minus 2 sine square a. You see the same answer. Different. I just moved this one here. 2 cos square a minus 1. I used this one instead. You see, I still got the same answer. So all these things are very interesting if you understand your way around them. So the major thing you want to always do is remember the key identities. So the reason why you may have this different form is that depending on the kind of question you're solving, you may want to use one or the other. So if you see a question where, let's say you had cos 2a, let me give you a very quick example there, a very important one. Look at something now, guys. Imagine you have a question that says cos 2a, this question I'm writing is very interesting. I like it. I wished I even examined you on it. Let's say minus 2. Look at this question now. Good. Are you guys flowing? Pay attention to what I just wrote. Cos 2a equals to sine a minus 2. I say solve this expression. Solve this expression. If you're not very smart enough to recollect what you're doing, you would look at this as a very difficult work. And it's quite very simple. You just need to recollect your identities. So now, but what I want to really use this to explain is why you have these different forms. Now, this is cos 2a here. I can express this cos 2a as this, or this. These are the three forms I could express it as. If I express it as this one here, this upper one here, I'm sure you see that I'm having cos square a minus sine square a. I'll be putting this here. So I'll be having I'll be having cos a, I'll be having sine a being featured, which is some of the things we don't want when solving trigonometric expressions. We want to always leave everything as 1. Now, if I go on to put this second form, 2 cos square a minus 1, if I put this as cos 2a instead of cos 2a, I'm writing this one now. Now, you can see that this one will be bringing out, we're having cos a and sine a, which is not what we want, because we'll be having two different identities, two different ratios, sine a and cos a. These are not the things we want to see when solving trigonometric expressions. What we really want to see is we want to see everything as just one ratio. That means one, if it's sine a we're having is just sine a. If it's cos a, we just have cos a. It could be cos square a, cos a, but as long as all we're seeing is just cos, nothing sine, nothing tan or anything. So look at the best thing to fill this one as in this expression is this third one, because I want to write now as 1 minus 2 sine square a equals to sine a minus 2. So if you look at this now, I obviously have 1 minus 2 sine square a minus sine a plus 2 equals to 0. Can you see this? So 1 and 2 will give, this will be minus 2 sine square a minus sine a plus 3 equals to 0. Are you seeing this? So I can go on now to multiply through with minus. This will be 2 sine square a plus sine a plus 3 equals, minus 3 equals to 0. And then I will go and solve this quadratically now. Of course, this is just a dummy example. All I wanted to bring out from this example is that, look at it. I have cos 2a here. I could use this, I could use this, I could use this. I will prefer to use this because this helps me to achieve the aim while solving a quadratic expression. So just imagine now that you know how to do all these things, but imagine you forgot your identities of double angle. Are you seeing why you will get stuck, why the question will look so difficult? Or let's say you did forget it, but you did not write it correctly. Let's say you made a mistake. So that's the key reason why people have issues with trigonometry. It's always on the basis of the identities. Identities plays a very, very super key role when dealing with trigonometry. Just know that once you don't know your identity, just understand that you're going to have lots and lots of problems in trigonometry. So one thing I would beg you to go and do now is probably this night, if you have not done it, go and start rehearsing the identities. Don't leave anyone unturned. The one you want, the last ones you may want to leave unturned, where you will see questions from. So you still have time now. Please use the time judiciously. Don't hesitate to know any of them, because it may look like it should not look like a dream when you are seeing questions and they require you to use there's no way you don't see trigonometry in your exam. I'm sure you know. Is anybody here not expecting trigonometry in the exam? There's no way you don't see trigonometry. You're going to have a good time with trigonometry in the exam. So please try and do yourself a very good favor by paying attention to all the identities. I've told you, if you understand all the workings I did, your major key will be in you knowing the identities. So look at this question we have right here. I want to solve this one for you so that at least you are refreshed. All right. Now, look at it. We have this question. What do you want to do right here? What you want to do is solve mathematically. And solving mathematically now will inform you that you want to drag this to this side, because obviously you want to collect likes and all the likes. So this will be 2 sine theta plus 25 degree equals to 2.532 minus 1. I'm sure this is good. So this will obviously give you 2 sine theta plus 25 degree equals to this will be 1.532. Of course, you can see what I just did. All I did now was to collect like terms. Now, of course, you want to divide both sides by 2. I'm just these things are very simple. You should not have any issue at all. So I divide both sides by 2, that will be 1.532 over 2. And this will give me 0.766. Are you seeing that? Now, this is where I really want to come to. The reason why I'm solving these questions for you is that look at something. Look at something. If you observe something here, you have a compound expression. And this is why I want to bring this to your notice. You have theta plus 25. You're going to deal with this theta plus 25 like just one angle. Don't get carried away with theta being here and thinking this is theta. This theta here doesn't represent the way. If I wrote sine theta here, if I say sine theta equals to 0.766, this theta here represented the whole angle you are dealing with. That theta here, this theta here doesn't represent the whole angle. This theta here represents just a part of the whole angle. The whole angle is theta plus 25. So you have to treat, all you have to do here is to ensure you are acting like as if the whole angle is theta plus 25. Don't act like as if theta, don't try to separate theta from 25. Theta plus 25 is the whole angle. So it's meant to obviously confuse you. For those of you for people that are not focused enough to understand what this means, they will probably want to think theta here is the theta here. Theta here is the theta here. The theta here is everything. The theta here is part of the whole thing. Remember that. Now, so what do you want to do? You're going to solve theta plus 25 like as if theta plus 25 is the whole thing. So I want to say theta plus 25. Don't forget, this is the whole angle. Equals to, if I want to find the arc sine, I'll say theta plus 25 equals to arc sine 0.766. So whatever answer I get, let's say for instance, I get, let me say I got 70 as the answer, for instance. For instance, I didn't say that's the answer, I said for instance. Let's say I got 70 as the answer. Let's say the answer was 70. All right. Look at it. Arc sine 0.766. Let's say it was 70. Please understand that this 70 is representing the whole compound angle theta plus 25 degree. Now, I said something. When you are told to solve an expression, please remember, it is the unknown that you are looking for, not this whole thing. This is not what they asked you to find. They didn't ask you to find theta plus 25. When they say solve an expression, what they ask you to solve is actually for you to get the result for that unknown. So that means the final answer you have must show theta. This theta, it doesn't show the whole angle here, but this theta must be your final answer because that's you solving the expression. So you need to, of course, this theta plus 25 now, we have gotten that the whole angle here was 70. So we're not going to act like this is the theta. This is not theta. So we can go on now to go and find theta. This theta here, of course, is part of the whole angle, not the whole angle. Is equal to 70 minus 25, which you will get as an answer. Of course, don't forget, I didn't tell you the answer here was 70. This is just a dummy. All right. You go on to press this yourself and do it on a calculator to get the right answer. Right? Now, after getting that, I want you to recollect something. That we're dealing with angle of any magnitude, right? Another angle of any magnitude, we know that we cannot say all these answers are our answers. I'm just trying to tell you that, just in case you, of course, normally I'm not even supposed to have even done this here. I'm not supposed to have done this. This is just me trying to explain to you why it is theta you are looking for. Let me use angle of any magnitude. Let me give you angle of any magnitude and let you understand how to solve this. When you are solving this, of course, this is sine of an angle and this is positive. So you're dealing with quadrant 1 and quadrant 2. Quadrant 2 is 180 minus whatever the angle was. Don't let me write theta here. Let me just write whatever the angle was. Let me say x, whatever the angle was. Because if I write theta here, some of you will be confused. If I wrote theta here, this theta here is not meaning this theta here. This theta here is the whole angle. The whole angle is what is represented with this theta here. So now, so in this case, that means that will be theta plus 25 as the whole angle. Let me just write it that way, the whole angle. So the first thing I want to do is to go on to find this. I've gotten this now. I've gotten this. Now, because we're dealing with quadrant 1 as our value, quadrant 1 is one of our value. Of course, this will just translate. Let's assume arc sine 0.766 is 70. You'll be having the first answer here, which is this represents the whole angle. You'll be having it as 70. Let's assume that. The other answer will be 180 minus 70, which I believe you know all this on that angle of any magnitude, and this will be, let's say, 110. I'm not saying these answers are correct though. So if you are trying to find this whole angle, this is your answer, 70 and 110. If this 70 was correct, I'm not saying it's correct. These are your two answers. But I want you to note one thing. When they ask you to solve, they are asking you to find the theta. So yes, theta plus 25 was 70. I didn't say 70 is the answer. You have to go on to now find whatever your theta was there. That means your theta here will be what? 70 minus 25, whatever that gave you. I'm not saying that's correct. The same thing happens in the second one. You have to go on and find it using your, if theta plus 25, if your final answer was 110, let's assume, of course, if you are done with this one, you got an answer. Look at your final answer with your final answer, theta plus 25, which is was giving you 110. You go on to say theta is equal to 110 minus 25. So what I'm saying here is that the main point to what I'm doing here is saying this question was given as theta plus 25 degree. This is the whole angle. You have to solve for the whole angle initially, which is what we did. The whole angle. We got the answer. But when you want to finally do your final summation, remember that they told you to solve it. The solution will be you bringing the value for the unknown. And theta here, you cannot say this theta and theta plus 25 are two different things. Theta here is a part of the whole. The whole is theta plus 25. So you have to go on and find theta, which is, if theta plus 25 was 70, that means theta will be 70 minus 25. If theta plus 25 was 110, that's the whole angle 110. That means theta will be 110 minus 25. So that's basically what I'm trying to submit to you. Do you guys flow with this? Hope this is not looking difficult for you. Were you able to flow with this? This is just like a part of trigonometry, all right? So yeah, and I want to, I'll be very honest, I want to congratulate you guys. Some of you are really doing your best, and I really I cannot also give my high sleep, because if you are doing your best and you are putting in your best, I really want to see you get the result, get the goal. And that's why I also, I sent a message to you guys. We are also tired. It's not just you, but we don't stop when we are tired. We stop when we're done. And if we have not gotten the goal, we don't want to stop. And that's why I'm challenging you guys to keep on keeping on. Don't feel it's been too intense. Just keep up, keep on. It's just the way it is. I want to explain certain things around calculus. I really do, but I don't know when that can be, because there are several aspects I still want to explain. I don't want you guys to have any issues at all. I want the answering of this question to be so seamless. I want you to have joy in solving mathematics, but we need time. The solution to these things are going to come with time. You have to learn them, and that's why I'm still calling for these revision classes. So now, can I say we are done? Is there any aspect of matrix or trigonometry that is still bothering any of you right here? Because we are no longer going to be talking about these two things. We have conic section. We have, what's the name of this? We have complex numbers. We have polynomials. We have functional mapping, right? That I want to still talk about. And tomorrow, by grace, we'll be meeting the same time, 8 o'clock. So I really want you guys to please be here on time. Ensure you, this is just, I understand many of you may not even have the time to open up some of these things again. So I'm trying to help you guys to refresh your memory, and at least you will recollect all these things when you see them in the exam. Or now, let me quickly tell you guys something. In every question we have solved today, you're going to see some questions, or at least a question. So please ensure you take your notes serious. And same thing is going to happen for that thing. I'm going to be revising. If it's not the same question, it's going to be very close to the same question. You are going to see very, very similar questions or the same question. It's going to be any of them. So I cannot tell you which one is going to be, but just make sure you are paying real attention to what we're doing. And you are always going to take notes and follow through on it, so that when you see these questions, you're doing a CBT exam, so you are able to quickly solve them. So guys, one of the take home from this is make sure you go on to know all your identities. Very key. And tomorrow I'm hoping to get into functional mapping, because I want to also talk about this bijective. Somebody complained about not remembering or probably not knowing bijective, surjective, and injective mapping. I want to see how to give some examples on that. And I also want to see something around binomial expansion. Somebody asked right in this class about what's the name? This negative binomial power. I want to explain that also tomorrow, and also explain some other concept under binomial expansion, so that we can at least do justice to that. This video will be released by God's grace sometimes in the afternoon tomorrow, so you can check up on it so that you can go back to them. All right. Every question we're solving are going to be very tangible questions. So it will really help you. It will really help you to make good preparations. So please ensure you come on time. Ensure you charge up your phones and do the needful. All right. So I really feel you guys are doing great. I love your energy. I love that you are not giving up. Don't give up. All right. This is just a pathway to success. So we're going to do lots and lots of more classes, and we'll talk more. Of course, I want to get into calculus. We're still going to get into calculus. I don't know exactly when, but please just stay in touch. Calculus is very, very important. We have to delve deeper into calculus, so that and also statistics. We will also do some things on statistics also, because statistics, we're getting into permutation and combination. That's a very interesting topic. Permutation and combination. We will need to solve lots of questions. Whatever we do in class will just be a part. Would need to come here to solve more questions. We cannot exhaust questions there. So guys, stay in touch. I'll be seeing you tomorrow in a bit. So make sure you do the needful, cram the identities, and make sure you are up to speed with every one of them. So guys, this is where I'm going to be leaving you for this night. All right. It's been a great moment. Ensure you enjoy yourself. Burn the midnight oil. Make sure you touch every topic. All right. Thank you very much. You have a good night. Bye-bye.